Hi everyone. In this video, I'm going to prove some trigonometric ratios and apply them to solve some examples. Let's get started. Now the three main trigonometric ratios when theta is the general angle are sine theta. This can also be written as sin theta. We also have cosine theta, which can be shortened as cos theta, and tangent theta, which can also be written as tan theta. Now there are other three trigonometric ratios that are reciprocals of these basic trigonometric ratios. We have cosecant theta. It can be shortened as cosec theta, and it is 1 divided by sine theta. So cosec theta is equal to 1 divided by sine theta. We also have secant theta, which can be written as sec theta and is equal to 1 divided by cos theta. So sec theta is equal to 1 divided by cos theta. And we also have cotangent theta, which can be written as cot theta and is equal to 1 divided by tan theta. So cot theta is equal to 1 divided by tan theta. Consider this right angled triangle. Let's name here x, here y, and here r, and put an angle here theta. Where the angle theta is facing is always the opposite, and where the 90 degrees is facing is the hypotenuse. The other side left is the adjacent. From SOHCAHTOA, so means sine theta is equal to opposite over hypotenuse. So we have sine theta is equal to the opposite, which is y, over hypotenuse, which is r. Let's call this equation 1. And from CA, it means cos theta is equal to adjacent divided by the hypotenuse. So we have cos theta is equal to the adjacent, which is x, divided by the hypotenuse, which is r. This is equation number 2. And from TOA, it means tan theta is equal to opposite over adjacent. So we have tan theta is equal to the opposite, which is y, divided by the adjacent, which is x. This is equation number 3. Let's divide equation 1 by equation 2. That will be sine theta divided by cos theta is equal to y divided by r divided by x over r. Let's change the division to times and reciprocate x over r. So we have r divided by x. So the r can cancel out, and sine theta divided by cos theta is equal to y divided by x. But y divided by x is equal to tan theta. So we will replace y over x with tan theta. So sine theta divided by cos theta is equal to tan theta. That is another identity. Tan theta is equal to sine theta divided by cos theta. And also from cot theta is equal to 1 divided by tan theta, we can get another identity. So from cot theta is equal to 1 over tan theta, we can write this as cot theta is equal to 1 divided by tan theta, which can be written as cot theta is equal to 1 divided by tan theta is sine theta over cos theta. So write sine theta divided by cos theta. So cot theta is equal to 1. We'll change the division sign to multiplication sign and reciprocate sine theta over cos theta. So we have cos theta divided by sine theta. So cot theta is equal to 1 times cos theta is cos theta. So we have cos theta divided by sine theta. Cot theta is equal to cos theta divided by sine theta. And also from Pythagoras theorem, the hypotenuse square is equal to the sum of the squares of the other two sides. So we have x squared plus y squared is equal to r squared. Let's name this equation number 4 and this be equation 5. So this will be equation 6. So we are going to divide equation 6 by r squared. So dividing through equation 6 by r squared, we have x squared divided by r squared plus y squared divided by r squared is equal to r squared divided by r squared. We can write this as x divided by r all squared plus y divided by r all squared, and r squared divided by r squared is 1. But x over r is cos theta. So let's replace it. You have cos theta squared plus y over r is also sine theta. So we have sine theta squared is equal to 1. And this can be written as cos square theta plus sine square theta is equal to 1. Cos square theta means cos theta all squared. And so this is another trigonometric identity. Sine square theta plus cos square theta is equal to 1, since addition is commutative. So either cos square theta plus sine square theta is equal to 1, or sine square theta plus cos square theta is equal to 1. Let this be equation number 7. From equation 7, we have sine square theta plus cos square theta is equal to 1. Dividing through equation 7 by sine square theta, we have sine square theta divided by sine square theta plus cos square theta also divided by sine square theta is equal to 1 also divided by sine square theta. Sine square theta divided by sine square theta is 1, and we can write this as cos theta divided by sine theta all squared. And we can also write this as 1 divided by sine theta all squared, since 1 squared is 1. And also cos theta divided by sine theta is equal to cot theta. And 1 divided by sine theta is cosec theta. So we have 1 plus cot square theta. Since cot square theta is the same as cot theta all squared, is equal to cosec square theta. Let's name this equation number 8. So we have another identity. 1 plus cot square theta is equal to cosec square theta. And again, dividing through equation 7 by, this time around, cos square theta, we have sine square theta divided by cos square theta plus cos square theta also divided by cos square theta is equal to 1 divided by cos square theta. So we can write this as sine theta over cos theta all squared plus cos square theta divided by cos square theta is 1. And we can also write this as 1 divided by cos theta all squared. But sine theta divided by cos theta is tan theta. And 1 divided by cos theta is sec theta. So we can write this as tan square theta plus 1 is equal to sec square theta. This is equation 9. So we have this identity, tan square theta plus 1 is equal to sec square theta. And now let's solve some questions. Simplify 1 divided by 1 minus cos theta plus 1 over 1 plus cos theta. So first of all, let's take LCM. The LCM is 1 minus cos theta multiplying 1 plus cos theta. 1 minus cos theta cancels 1 minus cos theta, and we have 1 plus cos theta multiplying 1, which gives us 1 plus cos theta. And 1 plus cos theta will also cancel 1 plus cos theta, leaving 1 minus cos theta times 1, which is also 1 minus cos theta. 1 minus cos theta times 1 plus cos theta is difference of two squares, right? So 1 minus cos theta times 1 plus cos theta is 1 squared minus cos theta squared. That is cos square theta. But let's expand. We will arrive at the same answer. At the numerator, we have 1 plus 1 is 2. And cos theta minus cos theta is 0. And let's expand the denominator. So 1 will multiply everything in this bracket. That is 1 times 1 plus cos theta. And then minus cos theta will also multiply everything in this bracket. 1 plus cos theta. So we have 2 divided by, this will give us 1 times 1 is 1. 1 times cos theta is cos theta. Minus cos theta times 1 is cos theta. And negative cos theta times cos theta is minus cos square theta. So we have 2 divided by cos theta minus cos theta is 0. So we have 1 minus cos square theta at the denominator, which is equal to this. Now from equation 7, we know that sine square theta plus cos square theta is equal to 1. So making sine square theta the subject, we have sine square theta is equal to 1 minus cos square theta. So we can replace 1 minus cos square theta with sine square theta. So we have 2 divided by sine square theta. This can be written as 2 outside, then we have 1 divided by sine square theta. Since 2 times 1 is 2. So 2 outside, we can also write this as 1 divided by sine theta all squared. Since 1 squared is 1 and sine theta squared is sine squared theta. So we have 2 here, and 1 divided by sine theta is cosec theta squared. So the answer is 2 cosec square theta. Simplify 1 over 1 minus sine theta plus 1 over 1 plus sine theta. So let's take the LCM. We have 1 minus sine theta multiplying 1 plus sine theta as the LCM. And 1 minus sine theta will cancel 1 minus sine theta, leaving 1 plus sine theta times 1, which is still 1 plus sine theta. Plus, now 1 plus sine theta will also cancel 1 plus sine theta, leaving 1 minus sine theta times 1, and it's still 1 minus sine theta. At the numerator, sine theta minus sine theta is 0, and 1 plus 1 is 2. At the denominator, 1 minus sine theta times 1 plus sine theta is difference of 2 squares. If we expand and simplify, we will arrive at 1 squared minus sine theta squared. That is sine squared theta. So we have 2 divided by 1 minus sine squared theta. But sine squared theta plus cos squared theta is equal to 1. Sine squared theta plus cos squared theta is equal to 1. So if we send sine squared theta to the other side of the equation, we have cos squared theta is equal to 1 minus sine squared theta. So 1 minus sine squared theta can be written as cos squared theta. So this ratio becomes 2 divided by cos squared theta. This can be written as 2 outside and then 1 over cos squared theta, since 2 times 1 is 2. So 2 outside, 1 divided by cos theta all squared, since 1 squared is equal to 1, and cos theta squared is cos squared theta. But 1 divided by cos theta is sec theta. So we have 2 sec squared theta as the answer. Show that sin x tan x plus cos x is equal to sec x. So we are going to simplify the left hand side to arrive at sec x. We have sin x tan x plus cos x. Tan is equal to sine divided by cos. So tan x is sine x over cos x. When simplifying trigonometric identities, One method is to change all the trigonometric ratios into sine and cos before you simplify. So tan x is sine x divided by cos x, and sine x times sine x is sine square x divided by cos x plus cos x. Cos x is over 1. Let's take the LCM. The LCM is cos x. Cos goes into cos 1. 1 times sine square x is sine square x. 1 goes into cos x, cos x. Cos x times cos x is cos square x. But sine square x plus cos square x is equal to 1. So we have 1 here divided by cos x. And 1 divided by cos x is sec x. Simplify. 1 minus sine square x divided by cosec square x minus 1. We have 1 minus sine square x divided by cosec square x minus 1. This can be written as 1 minus sine square x divided by cosec square x minus 1. We know that sine square x plus cos square x is equal to 1. Sine square x plus cos square x will give us 1. So if we send sine square x to the other side of the equation, we have cos square x is equal to 1 minus sine squared x. So we can replace 1 minus sine square x with cos square x. And also we know that 1 plus cot square x should give us cosec square x. So cot square x is equal to cosec square x minus 1. So we can also replace cosec square x minus 1 with cot square x. So in this bracket we have cos square x divided by this bracket we have cot square x. But cot x is equal to cos x divided by sine x. So cot square x is cos square x divided by sine square x. And we can change the division sign to multiplication and reciprocate cos square x divided by sine square x. So we have sine squared x divided by cos square x. So cos square x can cancel and we have sine squared x as the final answer. Prove that Square root of 1 minus sine A divided by 1 plus sine A is equal to sec A minus tan A. So we have square root of 1 minus sine A divided by 1 plus sine A. We are going to rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. The conjugate of 1 plus sine A is 1 minus sine A. So we have square root of 1 minus sine A divided by 1 plus sine A times 1 minus sine A over 1 minus sine A. Because 1 minus sine A divided by 1 minus sine A is 1. 1 times this will give us this back. So we have square root of, this is 1 minus sine A squared. 1 minus sine A times 1 minus sine A is 1 minus sine A squared. And the denominator is difference of two squares. 1 plus sine A times 1 minus sine A is 1 squared minus sine square A. If you multiply 1 plus sine A by 1 minus sine A, you will arrive at 1 squared minus sine square A. So we have square root of 1 minus sine A squared divided by 1 minus sine square A. But we know that sine square A plus cos square A is equal to 1. Sine square A plus cos square A is equal to 1. So making cos square A the subject, we have cos square A is equal to 1 minus sine square A. So we can replace 1 minus sine square A with cos square A. So we have square root of 1 minus sine A squared divided by cos square A. And this can be written as 1 minus sine A divided by cos A all squared. So the square is affecting both the numerator and the denominator. So the square can cancel out the square roots. So we have 1 minus sine A divided by cos A, which can be written as 1 over cos A minus sine A over cos A. But 1 over cos A is sec A, and sine A over cos A is tan A.